The magnetosphere. The magnetosphere is a region of magnetic field surrounding a celestial body like Earth, our planet. The Earth's magnetosphere acts like a giant bar of magnet because of its double poles. Like a magnet whose poles are tilted 11 degrees from Earth's rotational axis, with poles in northern Canada and Antarctica. Its magnetic field extends into space, protecting Earth from charged particles from the Sun and distant sources. Similar to Earth, other planets in our solar system possess magnetospheres. However, Earth's magnetosphere is the most robust among the rocky planets. This comet-shaped shield has been crucial for maintaining Earth's habitability by protecting it from solar and cosmic radiation and preventing atmospheric erosion caused by the solar wind. The magnetosphere is a dynamical system that responds to solar, planetary, and interstellar interactions. Recall that we have mentioned the solar wind in our previous series. Please watch our other videos on the ionosphere and solar wind. The Sun emits a steady stream of electromagnetic and particle radiation known as solar wind. This wind interacts with Earth's magnetosphere, stretching it into a comet-like tail called the magnetotail. The solar wind compresses the sun-facing side of Earth's magnetic field, extending it to about 6 to 10 Earth radii. The opposite side, or night side, forms a magnetotail that can stretch hundreds of Earth radii, reaching beyond the Moon's orbit at 60 Earth radii. The magnetospheric magnetic field is formed from the internal dynamo of the Earth. Now you may ask, what is a dynamo? A dynamo is a rotating conducting system that creates continuous current and produces an associated magnetic field. Inside the Earth, the metallic core is divided into two components, the solid metallic inner core and the molten metal outer core. The molten metallic outer core has been suggested to be in a molten state due to tidal heating. It consists of ionic materials and charge carriers. The rotation of the Earth creates a Coriolis force, which causes the rotational movement of the molten outer core around the inner core. This results in the movement of ionic charge carriers in the molten outer core. The effect of the movement of the outer core is that it creates circulatory current, which creates its associated magnetic field. Because the magnitude of the current is large, it creates a correspondingly large magnetic field, with its magnetic flux covering the Earth and extending beyond the Earth. The strong magnetic flux covering the Earth creates the magnetosphere on interaction with the solar wind. As we mentioned earlier, the magnetosphere serves as a protective shield for the Earth against the possible solar wind erosion effect. It also protects the Earth from other forms of cosmic radiation. Someone may ask, what would the Earth be like without the magnetosphere? Due to the solar wind erosion, the Earth would be stripped of its protective layers. The Earth would become like another Mars. Different scientific outputs have suggested that Mars is a barren world as we see it today because it lost its magnetosphere a long time ago, about 4.2 million years ago, according to scientific records. Geomagnetic storm is a way by which the magnetosphere releases the energy absorbed from the Sun while protecting the Earth from solar winds. Geomagnetic storms occur when the magnetosphere interacts with the solar wind, absorbing energy from the Sun. This energy is accepted through magnetic lines of force into the magnetic poles. The magnetosphere then releases this energy as either a storm or a substorm. Some solar wind particles break through and get trapped in the magnetosphere. As plasma enters through polar openings, it creates auroras around the magnetic poles along with geomagnetic storms. The magnetopause is the boundary where the solar wind meets Earth's magnetic field. This boundary shifts constantly because of changes in the solar wind. Although the magnetopause offers some defense against the solar wind, it also allows energy, mass, and momentum to pass into Earth's magnetosphere. The solar wind's interaction with Earth's magnetic field, atmosphere, and ionosphere generates fields, plasmas, and currents in the magnetosphere, including the plasmasphere, ring current, and radiation belts. As a result, the conditions inside the magnetosphere are highly dynamic, producing what we call space weather, which can impact technological systems and human activities. For instance, the radiation belts can impact satellite operations, while particles and currents from the magnetosphere can heat the upper atmosphere, leading to satellite drag that affects the orbits of low-altitude Earth-orbiting satellites. Additionally, influences from the magnetosphere on the ionosphere can disrupt communication and navigation systems. These phenomena are discussed in greater detail in our other videos and some other upcoming videos. Researchers from NASA European Space Agency, ESA, space science institutions around the world and universities study the magnetosphere to understand space weather, uncovering the fundamental physics shaped by electromagnetic forces. By observing our local space, scientists gain insights into the broader cosmos. This research helps refine space weather models and mitigate negative effects on spacecraft space-based technologies like satellites, ground-based technologies like power grids and communication systems. The different studies include understanding the nature of the electromagnetic phenomena in near-Earth space, how near-Earth space responds to external and internal stimuli, how the coupled middle and upper atmosphere respond to external factors, and how the various regions of the magnetosphere and upper atmosphere interact with each other. We are thankful for the abundant educational materials from different articles and sources from different bodies such as NASA, NOAA, European Space Agency, ESA, and other scientific research and educators. To encourage us in producing more content like this, please subscribe to our channel, like and share the videos with your friends, and click the notification bell for latest uploads.